I teach the Building Information Modeling class in the Civil Architectural Environmental Engineering department here at UT. And as part of the BIM class, we cover scheduling and 4D simulation and include Synchro in the students' experience. The reason why I think the students would benefit from the Synchro Challenge is that they could really experience the full capabilities of Synchro in a real-world active project, which was a great experience for the student team.
So there are over 150 buildings on UT main campus, and every year we build an additional 1 or 2 buildings, so that's a lot of construction activity. We thought it would make sense to try to pair up with one of these project teams.
The project we call EERC, Hensel Phelps was awarded the project in 2011.
We began construction in the fall of 2014. And it's a 3-year project. We're scheduled to finish this summer. We've been all the MEP. We had very, very good success in getting everything to fit through the use of BIM. Did not use any 4D or Synchro or any of that kind of scheduling. All our scheduling was traditional.
As the Synchro Challenge team came to me and said, what were some particularly difficult areas that you wish you would have synchroed?
We had some brainstorming sessions with the project manager and his team where he introduced us to 2 specific case problems related to the project, and we felt that they kind of resonated with our idea how we wanted to use 4D into simulating the challenges in the project and to achieve fruitful results using that.
The people at Hensel Phelps and the entire team at the Engineering Education Research Center have been exceptionally helpful. They gave us a tour of the construction site, they gave us access to all of their project documents, they answered our questions, and over the course of this interaction, we realized that because of their extensive use of 3D modeling, that project was the perfect candidate for 4D scheduling.
The first problem he introduced us to was related to the auditorium of the building, which is placed right next to the 2 towers of the building, and its construction was unique in a sense because it required intermingling of 2 or more different types of trades at the same time, including structural, HVAC and electrical. Temporary truss in the deck was created to install a working platform for the crew so that they could get on it and install the sunshade on the roof level. The installation and the removal of this temporary truss structure was quite challenging because it had to be slid in between the 2 towers that were already existing, and when the sunshade was finished, the installation was finished, it had to be slid back out using a crane.
In real BIM applications, 4D simulation contributes a lot of aspects throughout the construction phase. First, in terms of communication, it allows contractors to simulate and evaluate the planned construction sequence and share it with other stakeholders in the project. Another important aspect is coordination. Contractors can coordinate the expected time and space flow of different trees on the site. In addition to that, project managers can compare the road schedule with the planned one easily, and then they can quickly identify whether the project is on track or behind schedule.
As soon as Hensel Phelps began sharing their Revit files, the team was immediately worried that when all the models were consolidated in the Synchro file, that model navigability and lag would become an issue. But Synchro was surprisingly able to handle a large volume of data very well and provided a smooth experience. The ability to capture and pan between keyframes were great production tools, and we look forward to using it in the future and promoting it within the industry.
My name is Fernanda Leite, and I'm an associate professor at the University of Texas at Austin.
I'm Dr. Kirby Kuntz. I am a project manager for Hensel Phelps Construction Company.
My name is Thomas Czerniawski.
I'm Dave Kathuria.
And Yang Xu.
We are Team UT Austin. Welcome. Yeah,